This presentation is introduce a conceptual and methodological framework for hybrid AI assist qualification and transdisciplinary knowledge in glossal linguistics. This this workshop was created by me and José Maria. The main idea is that Glossal Lab is not being presented as a simple repository or an automatic AI system. It is being presented as a federated environment for transdisciplinary knowledge qualification. Transdisciplinary research requires more than bringing disciplines together. It requires the capacity to connect concepts, methods, and assumptions across different knowledge domains while preserving the diversity that makes its disciplinary contribution meaningful. This works with four quality dimensions: epistemic diversity, semantic coherence, clarity, and validation strength. The AI layer is not used to decide whether knowledge is valid. Its role is to assist the process by extracting concepts, identifying candidates, relations, supporting semantic mapping, and making structural patterns visible. The important point is that these outputs remain provisional. They must be traced back to source and reviewed by expert communities. This presentation proposes a conceptual and methodological framework for hybrid AI-assisted knowledge integration and qualification in Glossal Lab Dixit. The framework addresses a central challenge in transdisciplinary knowledge systems: how to preserve epistemic diversity while improving semantic coherence, clarity, and validation strength. Hybrid AI is used as an assistance layer to extract concepts, map relations, support clarity, assessment, and generate preliminary indicators. However, AI is not treated as an autonomous evaluator of knowledge quality. Expert communities remain responsible for knowledge clarification, co-creation, interpretation, validation, and refinement too. The proposal positions Glossal Lab Dixit as a federated environment for conceptual clarification, semantic structuring, and transdisciplinary knowledge clarification. The principal goals, I will present four from them. The first goal is to qualify transdisciplinary knowledge without reducing it to automatic similarity. The second goal is to balance epistemic diversity, semantic coherence, clarity, and validation strength. The first goal is to keep AI output source grounded and reviewable. The final goal is to support a cycle of expert-led corpus refinement. The core message is that hybrid AI should make knowledge structures visible. Experts should decide what is meaningful, valid, and useful across the disciplines. In this slide, we have the proposed framework. And is therefore not to automate the adjustment of knowledge quality, but to support a controlled and reviewable process through which conceptual relations can be extracted, mapped.
Teresa, wait a moment. You have the window open in which we see us, and we cannot see properly your slide because it's in between.
Close the
close the window of the Meet Google. You might see. Don't you see in the one that you see us, because it is intercepting?
This.
Yes,
exactly.
You can close it.
Sorry.
And click on hidden on hide. You see in the
when it's set ocultar. There.
Perfect.
Now,
thank you so much. Okay, no problem. Thank you. The aim of this framework is to show how Glossal Lab Dixit can support transdisciplinary knowledge integration and qualification through a controlled human AI process. The first point to clarify is that this framework is not designed as a simple repository model. Glossal Lab Dixit is not treated here as a place where publications, glossary entries, or conceptual descriptions are only stored. Instead, it is understood as a federal environment where knowledge objects are semantically structured, connect, assessed, and progressively refined. This is important because transdisciplinary knowledge requires more than access to documents. It requires conceptual clarification, traceability, semantic coherence, and expert validation. The framework is organized into 6 interdependent layers. These layers should not be read as isolated modules, but as part of a continuous process. The first layer is the federated transdisciplinary corpus. These include index publications, interdisciplinary glossary entries, conceptual descriptions, definitions, source, authors, collections, review authors, and domain classification. This layer is the evidential base of the system. It preserves the diversity of the corpus because different collections and knowledge domains can keep their own focus and terminology while remaining connected through shared semantic structures. The second layer is semantic and linguistic extraction. At this stage, the system identifies candidates, concepts, terms, definitions, examples, domain markers, and grammatical relations. This is where local language models and linguistic tools can assist the process. For example, the system may detect how concepts are linked in sentence, such as when one component concept supports, depends on, limits, or clarifies another. However, these outputs are still candidates. They are not yet validated knowledge. The first layer is knowledge graph representation. Here, the extract components, concepts, and relations are represented as an explicit graph. Concepts, terms, source, authors, domains, and relations can become nodes, while definitional, hierarchical, methodological, analogical, or application-based relations can become edge. This is one of the most important parts of the framework because it makes conceptual relations visible and traceable. It also allows us to observe all different knowledge domains interact inside the corpus. The fourth layer is hybrid AI support. This layer combines local language models, embeddings, retrieval augmented generation, or RAG, graph-based metrics, and rule-based checks. Each component has a specific function. Language models can help extract terms, propose candidate relations, and identify unclear passages. Embedding can support semantical proximity analysis. Retrieval augmented generation can help keep AI assist outputs connect to control source in the corpus. In this context, RAG helps ensure that AI suggestions are grounded in the Glossal Lab corpus. The AI does not simply generate a plausible answer. It retrieves the relevant corpus segment first and then uses them to support the explanation proposed relations. In the case, the rule-based checks can help detect missing source, dense jargon, weak definition, or unsupported claims. However, the role of AI is deliberately limited. The framework does not assume that the AI can decide knowledge quality on its own. AI is used to make patterns visible, to suggest possible relations, and to help organize complex information. It supports the process, but it does not replace expert interpretation. The The fifth layer is knowledge, knowledge qualification. This is where the system generates preliminary indicators related to epistemic diversity, semantic coherence, clarity, and validation strength. These indicators are not final scores. They are signals that help researchers and experts understand where the corpus may be strong, weak, fragment, too uniform, unclear, or insufficiently supports. For instance, a concept may appear across many domains, but still lack a stable definition. Another concept may be highly connecting the graph, but too general to be useful. The indicators help identify such situations. The sixth layer is expert validation and corpus refinement. This is the epistemic control layer of the framework. Expert review assist suggestions, accept or reject proposed relations, correct weak links, add missing distinctions, improve definitions, and validate or reject indicators. Their decisions are then reintroduced into the corpus of the knowledge graph, and this creates the feedback loop shown in this image. This feedback loop is essential. It means that the system is not static. Every validation cycle can improve the corpus, refine the graph, and strengthen the quality indicators. Over time, Glossal Lab Dixit can become more coherent, clearer, and better support while still preserving epistemic diversity. The main idea of the framework is therefore a balance. On one side, hybrid AI increases the capacity to process, compare, and map large amount of transdisciplinary content. On the other side, expert communities remain responsible for meaning, adequacy, validation, and refinement. This balance is crucial because transdisciplinary knowledge cannot be reduced to automatic similarity, frequency, or occurrence. A relation may be statistical, plausible, and still be conceptually weak. Conversely, a relation may be highly important if it connects distant knowledge domains in a meaningful way. For this reason, the proposed framework positions Glossal Lab Dixit as a human-supervised knowledge qualification environment. Its purpose is to make the structure of transdisciplinary knowledge more visible, more accessible, and more open to improvement. Hybrid AI supports extractions and mapping, but knowledge qualification remains grounded in source, semantic structure, and expert judgment. The central contribution of these frameworks to define the layer framework is useful but controlled, where diversity is preserved but structured, and where clarity is improved without losing conceptual precision. Now, one important point, the validation strategy that we propose to use. After presenting the layered framework, the next question is how this framework can be applied in practice and how its output can be validated. This is important because it proposes a realistic validation path that can guide future implementation. The validation strategy is designed as an interactive process. It begins with a bounded pilot corpus and ends with a refinement of the corpus and the knowledge graph. The aim is not to automate knowledge quality, but to test whether hybrid AI can support a more visible, traceable, and reviewable process of transdisciplinary knowledge qualification. Then the first step is the pilot corpus. This corpus should be limited but conceptually rich. It may include the index publications, glossary entries, conceptual descriptions, definitions, examples, and review annotations from GlossaLab Dixit for or previous GlossaLab materials. The research for the reason for starting with a bounded corpus is methodological. If we try to validate the whole platform at once, the process becomes too complex and difficult to control. A pilot corpus allows us to test the framework gradually with enough diversity to be meaningful, but with enough control to allow expert review. The pilot corpus should include concepts that cross disciplinary boundaries. Examples may include information, systems knowledge, complexity, intelligence, sustainability, or model. These concepts are useful because they often appear in several fields, but not always in the same meaning. These make them appropriate for testing whether the system can distinguish terminological overlap from genuine conceptual integration. The second step is the annotate the reference corpus. Before evaluating the AI assist workflow, we need a reference set created by human experts or trained annotators. This annotates corpus works as a comparison base. It should include manually identify concepts, terms, definitions, examples, relation types, knowledge domains, and source anchors. This is essential because we cannot evaluate extraction accuracy without knowing what the system should have found. This stage also requires clear annotation rules. If the categories are too broad, the annotations become vague. If they are too narrow, annotators may disagree too much. For this reason, the annotation team should define relations type carefully, such as the definitional relation, hierarchical relations, methodological, dependency, analogy application relation, and contrast or cross-domain correspondence. The first step is AI assist extraction. At this point, local language model and linguistic tools are used to identify candidate concepts, definitions, grammatical relations, and possible links between concepts. The figure shows this as an AI support stage, but it is important to stress that the outputs are still provisional. They are candidates for analysis and validation, not validate knowledge. For example, the system may detect that one concept supports another, depends on another, contrasts with another, or clarifies another. These grammatical and semantic patterns can help generate preliminary conceptual maps. But, however, the system may also produce weak or misleading relations. This is why the next stages are necessary. The fourth step is technical and semantic evaluation. Here we assess whether the system performs adequately at different levels. For extraction accuracy, we can use precision recall and F1 score. F1 score is a balanced measure, a measure of precision and recall. In this context, it helps evaluate whether the AI can identify relevant concepts and relations without producing too many incorrect outputs or missing too many important ones. Precision helps us to understand how many extract items are correct. Recall helps us understand how many relevant items from the reference corpus were found. F1 score provides a balanced view when both incorrect extractions and misrelevant relations matter. However, extraction accuracy is not enough. A system may extract many relations correctly at the linguistic level and still fail to capture their conceptual value. That is why the evaluation also includes knowledge graph quality. The graph must be checked for accuracy, completeness, consistency, provenance, and traceability. In practical terms, this means asking whether the graph relations are supported by source evidence, whether important concepts are missing, or whether there are duplicate or contradictory links, and whether each relation can be traced back to a source segment. And the figure includes also source groundedness. This is especially important because the framework was retrieval augment generation. When the AI generates an explanation, a summary or a suggested relation, we need to verify whether that output is actually supported by the retrieved corpus segments. The question is not only whether the output sounds plausible, but the question is whether it is grounded in the source. For GlossalLab Dixit, then this means that the AI assist output should be set at claim level, not only at the level of generate response quality. The fifth step is expert validation. This is the most important stage from an epistemic point of view. Technical metrics can tell us whether the system extracts something correctly, but they cannot decide whether a relation is theoretically adequate or transdisciplinarily useful. Expert reviewers must inspect the proposed relation, their source evidence, their domain context, and their conceptual function. In this case, experts may accept a relation, reject it, correct it, qualify it, add a missing distinction, or request stronger source support. They may also decide that a relation is valid only in one domain and should not be treated as transdisciplinary. This is crucial because GlossalLab Dixit is not simply processing language. It is qualifying knowledge across domains.
Teresa, sorry, you need to try to finish.
Yes. May I just finish with the last step, or not?
Yes.
Okay.
Finish.
The last step is corpus and graph refinement. On expert validation is complete, the step corrections are reintroduced into the corpus and the knowledge graph. This produces an updated corpus, a revised graph, improved quality indicators, and traceable signs. The process then becomes iterative. The improvement corpus can be analyzed again, new indicators can be generated, and further validation cycles can be carried out. Okay, it's better to finish now, okay? I suppose that I passed the big general idea.
Thank you, Teresa. In a way, I'm a little bit embarrassed because you usually have to cut me instead of contrary. But on the other side, I'm happy that I'm not the only one. So,
I was thinking that.
Okay, that was a good revenge. No, thank you very much. No, the good point, the good thing is that you have Son, even though you were not yesterday, but we have been talking about that. It shows all the loop that how we integrate the artificial intelligence and how we have this human intervention, the curation, which for us is essential in several steps. But until now, we have mostly focused on consistency or coherence and diversity. But one of our main focus is on also bringing clarity. So indeed, this evening we will devote the whole session of the afternoon evening to the clarification processes, and clarification processes what has in the substantive is clarification. So we need clear also communication, which, by the way, there was a very interesting discussion after we shut down the cameras here, and Gurne was telling us, making a very good criticism, in the sense that very nice with transdisciplinary theories and so on, but I'm not understanding what you mean. So it is not clear. So you are kind of contradictory. So you want to provide a transdisciplinary setting that is good for bridging among different scientific disciplines, but I'm not understanding. Of course, there is one barrier that is created because we don't have the groundings. So, of course, the grounding is essential, and clarity needs to always to bear in mind that we need to ground our clarity on good roots. That's kind of the motto of the workshop. And for that, of course, we need to build up this theory, but we need clarity in several ways. For example, exemplification is one component, but we will see there are many other components, as was the ISO, the international standard organization standard for clarity is telling us we need to be clear. So for being clear has to be understandable, needs to have some components that we will discuss now, is for showing the different approaches. So this is what we are going to move now more into clarity, which is an essential component of our strive. So what we are trying to reach. So then for that, I let the word to Juan. Let's try to keep it short. Afterwards, I don't know if, by the way, I just stopped Teresa, sorry, and maybe there is some question that you want to pose to Teresa. Is any question or any comment before we move to the next? No? Okay. In any case, because tomorrow Daniel is going to show much of what was presented yesterday and what Teresa has clarified now. So then we can move to Juan. Let's try to keep it short. So for having the opportunity to discuss after. Thank you very much, Teresa, and thank you very much, Juan.